Okay, the screen is visible to all, is it?
Yes,
Okay,
yes, sir.
previously we seen that the first boundary value problem, that is Dirichlet problem. Okay, there are two types of that: interior Dirichlet problem and exterior Dirichlet problem. What is interior Dirichlet problem? So u of xy satisfies the Laplace equation in the region D, and u of xy coincide with f of s. Okay, that is u of u is coincide with f on the boundary of the region. Okay, where f is the continuous function on the boundary. Okay, similarly, for the exterior Dirichlet problem, f is the continuous function on the boundary, and the u of xy satisfies the Laplace equation inside the region D, that is u is harmonic, that is u double x plus u double y is equal to 0, and u of xy is coincide with f on the boundary B. Okay, so these are the two examples of Dirichlet problem, two types of Dirichlet problem. Okay, now the second boundary value problem is Newman problem. So in this problem, f is continuous function on the boundary B of the region D, then the problem determining function u of xy, that is such that del square of u is equal to 0, satisfies the Laplace equation, and dou u by dou eta is equal to f on the boundary B. Okay, so after that we seen that what is the maximum and minimum principle. Okay, if u of xy is the harmonic function in the bounded closed region D. Okay, and it is continuous on D bar, which is equal to inside of the whole region union with boundary. Okay, D union B. So we have to prove that the u attains its maximum value on the boundary of B, boundary B of region D. Okay, एखादा फंक्शन जर लाप्लास इक्वेशन सॅटिस्फाय करत असेल, ओके, तो जर हार्मोनिक असेल तर त्या फंक्शनची सगळ्यात मॅक्सिमम व्हॅल्यू कुठे येते तुम्हाला? त्या रिजनच्या बाउंड्रीवर तुम्हाला मॅक्सिमम व्हॅल्यू मिळते. हा थेरम सांगतो. ओके, एनी डाऊट इन दिस थेरम? काही डाऊट होतात का? आहेत का? काल खूपच फास्ट झाला होता थेरम शेवट. ओके, एनी डाऊट आहे तर काही डाऊट? Now today we have to prove that the uniqueness of the theorem. Okay, the solution of the Dirichlet problem, if it is exist, it is unique. एखाद्या Dirichlet problem ला जर सोल्युशन येत असेल तर तो काय असतो? युनिक असतो. हे आपल्याला प्रूव्ह करायचं. ओके, एनी डाऊट इन दिस थेरम? ओके, पुन्हा एकदा वाचा, वाचल्यानंतर व्यवस्थित कळेल. ओके, नाउ द नेक्स्ट पॉइंट इज युनिकनेस थेरम. Uniqueness theorem. Uniqueness theorem. What is uniqueness theorem? Region or question. Prove that the solution of Dirichlet problem. The solution of Dirichlet problem okay, if it exists, then it is unique. Okay, look at the proof. So what is the proof? If let u1 of xy, let एखाद्या प्रॉब्लेमला जर सोल्युशन येते ते आपण युनिक सोल्युशन असेल, हे आपण काय कसं करतो? लेट अस assume u1 and u2 are the two solutions. Okay, and define v is equal to u1 minus u2. If v is equal to 0, then u1 is equal to u2. Okay, so this is the method to prove the solution is unique for any problem. Okay, किंवा काय करावं लागेल? If u1 and u2 are the two solutions of that problem, and we have to claim that u1 is equal to u2. Okay, here is the method. Either u1 is equal to u2 दाखवा, or v is equal to u1 plus u2, u1 minus u2 असा डिफाइन करून v is equal to जर आपण 0 दाखवलं तर u1 is equal to u2. Okay, so here let u1 of xy, okay, and u2 is the function of xy be the two solutions of Dirichlet problem. Be the two solution of Dirichlet problem. If these are the two Dirichlet problems, solution of the Dirichlet problem, then it satisfies Laplace equation, that is del square u1 of xy is equal to 0 and del square u1 of xy is equal to 0 in the region D, and u1 of xy is equal to f, okay, f of s on boundary D. Okay, so this is the definition of Dirichlet problem, solution of Dirichlet problem. There f is the continuous function, where this f is continuous function defined on the boundary, defined on B. Okay. Similarly, for the u2, if u2 is the solution of the Dirichlet problem, then del square u2 of xy is equal to 0 in capital D, that is region, and u2 of xy is equal to f of s on the boundary B. Okay. Now claim. We have to prove that. Claim म्हणजे काय, जो आपल्याला प्रूव्ह करायचा तो what? We have to claim, the claim is u1 is equal to u2. Okay, so define first v is equal to u1 minus u2. Define v is equal to u1 minus u2. Okay, if we prove this v, a function v is constant, then sorry 0, then u1 is equal to u2. Okay, so here v is equal to u1 minus u2, so del square v is equal to, okay, del square of u1 minus u2, which is equal to del square of u1 minus del square of u2. Okay, del square म्हणजे काय तुमचा एखादा डिफरन्शियल ऑपरेटर आहे, डो 2 बाय डो डबल एक्स dx स्क्वेअर, ओके, असा काहीतरी तुमचा डिफरन्शियल ऑपरेटर आहे, आणि हा डिफरन्शियल ऑपरेटर काय असतो, लिनियर डिफरन्शियल ऑपरेटर असतो. दॅट्स व्हाय वी operate this del square on u1 and u2. Okay, so this is what is the del square u1 is 0, del square u2 is 0, is equal to 0. Hence del square v is equal to 0. Okay, give it an equation number 3rd, and this one to 1, this is equation number 1, this is the equation number 2. Okay, so as the del square u v is equal to 0, this implies v of xy is harmonic on D. Okay, this is the harmonic function on the region D. Okay, any doubt up here? Any doubt? No.
No, sir.
V of xy is equal to u1 of xy minus u2 of xy. Okay, what is the u1 of xy on the boundary? On boundary B. Okay, is f of s. This is f of s, which is equal to 0. on the boundary B. Okay, so V of xy is equal to 0 on the boundary B. But we know that by maximum and minimum principle, by maximum and minimum principle. Actually, जसं maximum value जर boundary वर येते तसंच minimum value पण तिथे boundary वरच मिळते तुम्हाला. Okay, that's why the theorem is called as maximum and minimum principle. Okay, maximum आपल्याला फक्त सिलेबसला फक्त याचाच स्कोप आहे maximum म्हणून. Okay, minimum चा नाही. जसे v of x y, u of x y ची व्हॅल्यू कुठे मॅक्झिमम मिळते आपल्याला प्रूव्ह केलेलं पण बाउंड्रीवर. तशीच व्हॅल्यू मिनिमम व्हॅल्यू पण कुठे मिळते तुम्हाला त्या बाउंड्रीवरच मिळते. Okay, so by maximum and minimum principle, we have the v of xy is equal to 0 put on the boundary. Okay, एखाद्या बाउंड्रीवर जर एखाद्या आपण त्यांची व्हॅल्यू 0 असेल तर काय होईल, हा v of xy is equal to 0 inside the region D also. कसं समजतंय का? बाउंड्रीवर तुमची सगळ्यात व्हॅल्यू जास्त आहे, पण सगळ्यात जास्त व्हॅल्यू कोण आहे इकडे? 0. ओके, म्हणजे त्याच्यापेक्षा लेस व्हॅल्यू तर काय असणार, निगेटिव्ह व्हॅल्यू तर असणार नाही v of xy ची. ओके, so v of xy is equal to 0. So this is the maximum value on the boundary B. Okay, it implies that v of xy तुमचा टोटल हा v of xy फंक्शन हा 0 असायला पाहिजे इनसाइड D. म्हणजे इनसाइड डोमेन रिजन D च्या आतमध्ये प्रत्येक व्हॅल्यूला तुमचं फंक्शन काय असायला पाहिजे? 0. हे कधी होईल? itself v हा जर 0 असेल तर itself v of xy is 0. Okay, so in D this implies u1 minus u2 of xy is equal to 0. In B, this implies u1 of xy is equal to u2 of xy in whole domain D. Okay, so that is thus the solution of the differential problem is unique. Okay, any problem? काही अडचण असेल तर विचारू शकता. Okay, so here this is the proof of the solution of Dirichlet problem. If it exists, then it is unique. Okay, now moving toward the next point. The next point is the Green's identity. Okay, what is the Green identity? Look at here. Green's identity. ओके, त्या ग्रीन आयडेंटिटीसाठी तुम्हाला ग्रीन फंक्शन काय माहिती, ग्रीन थेरम काय असायला काय आहे ते माहिती पाहिजे. ओके, इफ u is the function of xy, okay, capital U, and capital V is the function of xy are differentiable functions. Are differentiable functions in the region D. Okay, in the region D, and continuous on boundary B. Okay, u of xy, capital U of xy and capital V of xy are the differentiable function in D and continuous on boundary B of that region D. Then from the Green's theorem. Green's theorem. We have what we have this one. Integration on the region D of ux plus vy into ds. Okay, is equal to, as your integration is on the region D is equal to integration on the boundary B. Okay, of u into dy minus v into dx. So this is the Green's theorem. Okay, you get an equation number 1. पहा काय म्हणतोय, हा म्हणतोय ग्रीन्स थेरम काय म्हणतोय, हा जो काही इंटिग्रल येईल ऑन द रिजन डी, हा समजा तुमचा सेट असेल R2 चा, हा तुमचा डी आहे आणि हा बी असेल बाउंड्री. Integration of ux, differentiate this one with respect to x and this one with respect to y. Okay, so integration of ux plus vy into ds with respect to ds is equal to integration on that boundary region of boundary of a region is equal to v into dy. Integrate u with respect to dy and v with respect to dx. So this is the green theorem. Okay, so green identity after find out what is the green identity. Okay, so from green theorem we have this one. Now put capital U is equal to psi into phi. Okay, and capital V is equal to psi into phi y. Okay, in above equation. तर u हा तुमचा हा असेल तर ux काय use u into v. Okay, psi x into phi x plus psi into phi double x. हा तुमचा आपला ux. Okay, similarly vy काय येईल psi y into phi y plus psi into phi double y. Okay, now putting the value of psi ux and uvy in the equation 1. And psi and u and v also in equation number 1. हे सगळे value ह्याच्यात put करा equation number 1. So what we have the integration on the region D, okay, into bracket psi x, value of ux, psi x to phi x plus psi into phi double x plus psi y into phi y plus psi into phi double y ds is equal to integration on the boundary B, value of u dy. Okay, which value psi into phi x into dy minus psi into phi y to dx. Okay, so which implies integration on D. Okay, now this one psi x plus psi common. Okay, what we have then phi double x plus phi double y plus psi y phi y into ds is equal to integration on the boundary B, take psi common. Okay, psi into phi x dy minus phi y dx into ds. Okay, into ds. Now integration on D. Okay, what we have then psi x, this is psi into del square of psi phi. Okay, del square of phi plus phi y psi y into ds, which is equal to integration on B, psi into, now putting these values, value of this one is dou phi by dou eta. So ds, where dou phi by dou eta is into ds. Wait a minute. Is equal to dou phi by dou eta is equal to psi x dy minus phi y into dx. Okay, so give me condition number 2. Okay, now interchanging the role of interchanging phi and psi. Okay, आता काय करायचं, जिथे आपल्याला psi आहे तिथे phi ठेवायचं, जिथे phi आहे तिथे psi ठेवायचं. मग काय होईल, interchanging the role of phi and psi and subtracting from equation number 2. Okay, मग जेव्हा interchange करतो phi and psi and subtract from equation number 2, जेव्हा असं करेल तेव्हा काय, इंटिग्रेशन फ्रॉम g, इंटिग्रेशन ऑन d, हा तुमचा टर्म कॅन्सल होईल सबट्रॅक्ट केल्यानंतर, हा 0 येईल, हा 0 येईल. इथे काय येईल, psi into del square of phi minus subtract केल्यानंतर phi into del square of psi. Okay, this is ds into ds is equal to integration on d boundary b. Okay, हा काय येईल, psi dou phi by dou eta minus phi ठिकाणी काय येईल तर psi into phi into dou psi by dou eta. This is ds. Give it as an equation number 3. Okay, so interchanging the role of phi and psi and subtracting from the equation 2, so we get this one. Okay, हा तुम्हाला 0 येईल. Okay, so equation 2 and 3 are called as Green's identity. So equation number 2 and equation number 3 is nothing but Green's identity. Green's identity. Okay, first वेळेला बघ बघताल तुम्हाला जरा किचकट वाटेल, अवघड वाटेल, काय 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 हे आहे असं. Okay, equation 2 and equation 3 are called as Green's identity. घ्यायचा उद्देश काय, पुढे एका थेरम मध्ये याचा यूज होणार आहे म्हणून घ्यायचा. ओके, ग्रीन्स आयडेंटिटी किंवा एमसीक्यू ला वगैरे कधी काही वेळेस विचारू शकतो. ओके, एनी डाऊट, कॅल्क्युलेशन मध्ये काही डाऊट आहेत का?
No, sir.
Okay, now the next theorem is show that the necessary condition for the existence of the solution of Newman problem is that integration on boundary of f should vanishes. Okay. The next theorem, छोटा theorem, show that the necessary condition for the existence of the solution for the solutions of Newman problem is that integration on the boundary B of function f should vanish. What is the meaning of this sentence? एखाद्या न्यूमन प्रॉब्लेमचा जर सोल्युशन एक्झिस्ट झाला तर काय येईल, This implies integration of f on the boundary should vanishes. That means integration of f on the boundary is 0. Okay, integration of f on the boundary f is 0. Okay, what is the Newman problem? It satisfies the Laplace equation inside the region D and on the boundary f, dou n dou phi by what is the Newman problem? Dou u by dou eta is equal to f of s. Okay, where dou by dou n is the directional derivative along outward normal. ओके, हा तुमचा नेसेसरी कंडिशन आहे. नेसेसरी कंडिशन म्हणजे काय? एखाद्या न्यूमन प्रॉब्लेमला सोल्युशन एक्झिस्ट होतो. तर असं असेल, दिस इम्प्लाइज इंटिग्रेशन ऑफ f इज इक्वल टू 0 ऑन बाउंड्री. ओके, जर इंटिग्रेशन 0 असेल तर सोल्युशन एक्झिस्ट होतो. ही सफिशियंट कंडिशन झाली. ओके, सो हियर वी हॅव टू प्रूव्ह दॅट if u of x y be the solution of Newman problems, then capital integration of f of s is 0 on the boundary. Okay, look at the proof. Let u is the function of xy. Okay, u of xy be the solution. Be the solution of Newman problem. What is the meaning of solution of Newman problem? This implies del square u is equal to 0 in the region D and dou u by dou eta is equal to f of s on B. Okay, give it as an equation number 1. आणि आपल्याला काय प्रूव्ह करायचं आहे? We have to prove that integration of this function f on the boundary is 0. Okay, so where f is continuous function. On B. Okay, so we have to claim that first. Integration of f of s on the boundary B, okay, is equal to 0. Now we know that what is the Green's identity. Okay, त्या ग्रीन आयडेंटिटीचा उपयोग इथे होतो. We have to use that identity. म्हणून ते आपल्याला सांगितले. So we know that Green's identity is given by the Green's identity is given by. What is the Green identity? Look at here. This one. Okay, instead of u, okay, same. Equation number 3. Equation number 3. Integration on G of psi into del square of phi minus phi into del square of psi into ds is equal to integration on the boundary B psi into dou phi by dou eta minus phi into dou psi by dou eta with respect to ds. Okay, give it an equation number 2. So this is the Green's identity. Okay, now let us assume psi is equal to 1 and phi is equal to u in equation number 2. Okay, the psi is equal to 1 जर मी केला तर काय येईल? del square psi किती येईल? 0. Okay, phi double x psi double x plus psi double y काय येईल ती व्हॅल्यू? 0 येईल ना. Differentiate with respect to x करा, differentiate with respect to y and add करा, म्हणजे काय येईल? हा व्हॅल्यू 0 येईल. ओके, आणि dou psi by dou eta ही व्हॅल्यू किती येईल? डिफरन्शिएट दिस विथ रिस्पेक्ट टू eta हा आपण काय येईल? 0 येईल. म्हणजे ही टर्म सुद्धा 0 येईल, ही टर्म सुद्धा 0 येईल. Okay, so what we have then? So integration on the region D, this term happens to 1 into del square phi. Okay, sorry, phi is equal to u, phi is equal to u. Del square u into ds is equal to integration on B boundary. A term is हा वन वाला हा d phi phi म्हणजे काय तुमचा u dou u by dou eta into this one is ds. Okay, give it an equation number third. So using 1 in the equation number 3, using equation 1 in equation 3, we get what is the value of this one. If u of xy is the solution of Newman's problem, so it satisfies the Laplace equation inside the region D. So this is the 0. Value of this one is 0 is equal to integration on B. Okay, what is dou u by dou n? If u is the solutions of Newman problem, so dou u by dou eta is satisfies, it coincides with f of x. Okay, from equation number 1 into ds. So this implies integration on the boundary B of the function f into ds vanishes. That is equal to 0. Okay, any doubt? छोटे छोटे आणि खूप इझी एकदा तुम्हाला डेफिनेशन मध्ये असेल तर काही अवघड नाही आहे याच्यात. ओके, सो दिस इज द नेसेसरी कंडिशन. जर एखादा आपण काय अज्यूम केला आहे, हा तुमचा u ऑफ एक्स वाय हा सोल्युशन आहे आणि त्याच्यावरून काय प्रूव्ह केलंय, इंटिग्रेशन ऑन द बाउंड्री बी ऑफ द फंक्शन f इज 0. सो दिस इज द नेसेसरी कंडिशन. So if the solution exists, okay, for any Newman problem, okay, it implies that integration of f on the boundary b is equal to 0. हे MCQ ला विचारतात छोटे छोटे क्वेश्चन नेटला सेटला. ओके, नेटला नाही येणार, सेट आहे तिला. ओके, एनी डाउट अप टू हियर? आणि काय करतात सगळे स्टुडंट इथेच तुम्हाला ॲब्सेंट राहतात आणि नंतर म्हणायचं पेपर अवघड होता. ओके, हे दिसायला अवघड दिसतं पण खूप छोटे छोटे फक्त स्टेटमेंट विचारतात. तुम्ही स्टेटमेंट जरी वाचून गेलात त्याचा अर्थ समजून तर सेट क्वालिफाय होणं अवघड नाही. ओके, सो नेक्स्ट पॉइंट इज show that the solution of Newman problem is either unique or it differs from one another by constant. Okay, if u1 and u2 the दोन solutions असतील तुमचे न्यूमन प्रॉब्लेमचे. Okay, if u1 and u2 are the solutions of Newman's problem, then either u1 is equal to u2 or it differs from one another by constant. What is the meaning of this one? एक तर u1 is equal to u2 असायला हवा किंवा तो डिफर असायला पाहिजे. कशापासून? वन अनदर बाय कॉन्स्टंट. u1 is equal to c plus u2. डिफरन्स म्हणजे काय? दोघांचा डिफरन्स काहीतरी मला कॉन्स्टंट पाहिजे. ओके, you can go. Next one. Show that the solution of Newman problem is either unique, okay, or it differs from one another by a constant. Okay, look at the proof. Okay, let's u1 is the function of xy Okay, and u2 is the function of xy with two solutions, with two solutions of a Newman problem. Okay, what is the meaning of that one? So del square of u1 is equal to 0, which is equal to del square of u2 inside the region D. Okay, inside the region D. And dou u1 by dou eta is equal to f of s, which is equal to dou u2 by dou eta on boundary B. Okay, so this is the meaning of solutions of a Newman's problem. Now consider B is equal to, बघा जिथे जिथे एक स्लो करतो तिथे आपण मी डिफाइन करतो. Okay, consider that B is equal to u1 minus u2. Okay, so we see that, see, del square V is equal to del square of u1 minus u2, what the value of V is. Okay, so this is the linear of the derivative, u1 minus del square u2, which is equal to 0 minus 0 is equal to 0. This implies V is harmonic. V is the harmonic inside the region D. Okay, like question number 1. Del square of V is equal to 0. Okay, any doubt up to here? Okay, now dou V by dou eta is equal to dou by dou eta of u1 minus u2 is equal to dou u1 minus divided by dou eta minus dou u2 divided by dou eta is equal to f of s minus f of s on B, which is equal to 0 on B. Okay, give it an equation number 2. So this is the value of dou V by dou eta. Okay, so this shows that from equation 1 and 2, equation 1 and 2 shows that V is harmonic. Okay, V is the harmonic function, and dou V by dou eta is equal to 0 on the boundary B. Okay, any doubt up to here? Okay, so we have to claim
No, sir.
either V is equal to 0 or V is equal to constant. So V is equal to 0 असेल तर काय होईल? U1 is equal to U2. Okay, if V is equal to constant, then it differs from U1 and U2 are differ from one another by constant. Okay, so claim that. What is claim? Either V is equal to 0 or V is equal to constant. Okay, so we know that again by Green's identity used here. We know Green's identity is given by, okay, on equation 2 here. High equation is correct. Okay, this one. Wait a minute. Wait a minute. Okay. Okay. So use the Green's identity. This one. Which one? Wait a minute. Equation number 2. Okay, that is this one. Okay, okay, so write down. So we know that the Green identity is given by integration on the domain on the region D into bracket psi x phi x plus psi into phi double x plus psi y phi y plus psi into phi double y into ds. Okay, is equal to integration on the boundary B, which is psi into dou phi by dou eta into ds. Okay, so give it as an equation number 3. Okay, so this is the Green's identity. Now put in the above equation psi is equal to phi is equal to v in equation number 3. Okay, so what we get then? Integration on the region D is equal to, this is Vx, this is Vx, so we get Vx square, okay, plus, this is psi is equal to V, so V into V double X plus Vy into square, okay, plus V into V double Y, okay, into ds plus, is equal to, on the boundary B, okay, so this size is nothing but V and this is dou V by dou eta into ds. Okay, any doubt up to here? Find out it. Now,
No, sir.
take V common from this one. Okay, so this is the integration on G. Okay, and Vx square plus Vy square. So this is the value of del V bracket square. Vx square plus Vy square. Okay, this is the del of theta. What is del of theta? D by dx of I bar plus d by dy by j bar. Yeah, I bar. This is the del of theta on the V. Okay, square I square into ds. Okay, plus integration on D, taking V common from here, and V double x plus V double y is nothing but del square of V. Okay, this is the Laplace equation. V double x plus V double y into ds plus this term is as it is, integration V into dou V by dou eta into ds. Give it as an equation number 4. Now using 1 and 2, we get equation 1 and 2 तुमचा del square v किती येतोय 0. Okay, look at it. Del square v किती आहे 0. dou v by dou n किती आहे 0. Okay, now putting the value of equation 1 and 2 here, this is also 0. Okay, so we get, this implies that integration on the region D del v bracket square into dx is equal to 0. Give it as equation number 5. That's our second. Integration on the whole the region D is equal to 0. That's our second. So itself a function म्हणजे तुमचा इंटिग्रेशन म्हणजे काय असतं एरिया ना ओके जर तुमचा एरिया किंवा व्हॉल्यूम जर 3 डायमेन्शनल स्पेस मध्ये असेल तर व्हॉल्यूम असतो ओके किंवा ते काय असेल एरिया एरिया तुमचा 0 असेल तर फंक्शन इटसेल्फ काय पाहिजे तुमचा del v is equal to 0 on the domain D. Whole D वर तुमचा 0 असेल तर एरिया so itself a function del v is equal to 0. Okay, what is the del of the term? Del is nothing but as differential of the differential. Okay, so derivative of तुमचा 0 वाला whole domain, it means that v is equal to constant on the domain D. Okay, del of the cosine dou by dou x plus dou by dou y of plus dou by dou z. Okay. Function तुमचा किती व्हेरिएबल इंडिपेंडेंट व्हेरिएबल आहे त्याच्यावर. Okay, so here del v is equal to 0 on d. It implies that v is equal to constant on d. Okay, जर तो constant 0 असेल तर काय येईल u1 minus u2 is equal to 0 येईल. जर constant तुमचा c असेल तर काय येईल हा it differ u1 and u2 are differ from one another by constant c. Okay, so this implies u1 minus u2 is equal to constant on d. Okay, so if the constant is equal to 0, then the solution is unique. Okay, the solution is unique. Okay, otherwise it differs from one another by a constant. Okay, डिफरन्स काय होता डिरिचलेट प्रॉब्लेम आणि नॉर्मल प्रॉब्लेम मध्ये डिरिचलेट प्रॉब्लेमला जर एक्झिस्ट झाला तर युनिकच असतो. नॉर्मल प्रॉब्लेमला काय एक तर तो युनिक असायला हवा किंवा डिफर फ्रॉम वन अनदर बाय कॉन्स्टंट. एवढाच फरक आहे दोघांमध्ये डिरिचलेट प्रॉब्लेम आणि नॉर्मल प्रॉब्लेम. ओके, एनी डाउट? Okay. So in the next lecture, we will see the exterior Dirichlet problem for a circle. Okay, circle म्हणजे काय तुमचा region काय तिथे आता D काय तुमचा circle दिलेला. Okay, set of R2. Okay, subset of R2. The exterior Dirichlet problem for the region D, where D is the circle. तेव्हा तुमचा solution कसा येतो आपल्याला find it करायचं. Okay, so for today it is sufficient now. Okay, wait a minute, I will take an attendance. Okay, any doubt up to here? If no doubt, we can leave the lecture. Thank you for attending.